So today in class, we were graphing sine and cosine functions that have been translated. And so I wanted to run through an example of how we've been doing this. I chose number 24 because the graph I provided you doesn't fit exactly with the strategy that we were working with. So I'm going to show you how to make this one work, even though the values aren't lining up the way we'd hoped. So we start out the problem by listing our important values. So we need to list the amplitude. And the amplitude is that value that's multiplied in front of either the sine or the cosine. So in our case, the amplitude is going to be 5. That means our height is 10, right? We also have a vertical shift. That's the number that's added on the outside. Now in this problem, they snuck that thing in front for us, but it's the same as if we didn't have it. Oh, jeez. If we didn't have it out here in front, right, it could say plus 20 over here. It's still the vertical shift. Right? So either way. So we've been calling that the VS, and that means this whole thing gets moved up 20 units. The period is going to be 2 pi divided by 3. And we also have talked about the phase shift, the horizontal shift. We call that the PS. And the PS is the opposite of this number, pi, divided by 3. For us, that means negative pi over 3. And so there's a few things about the grid that I gave you that are frustrating. And I'll work through it with you, and you can sort of cheat off me on this one. There's some things that aren't, though. First of all, we have a vertical shift here of 20 units. That means our midline, which is normally the origin, the x-axis, is moved up here to 20. And we have an amplitude of 5. That means our high line is going to be up here at 25, 5 units above the midline. And our low line is going to be at 15, 5 units below that midline. So whatever happens with our graph, and we'll make this graph red just for the kick since that one down there is, it's going to happen in between here somewhere. Now normally at this point we would start by plotting our new starting point, right? And what we usually do is we take this point 0, 1, and the 0 we add negative pi over 3 to it, meaning that I'm going to shift this thing to the left pi over 3. The problem is pi over 3 really isn't displayed on our graph, so I'm going to have to fake it because I didn't give you enough room over here on the left. But essentially our new high point, right, we go high, low, high. Our new high point is over here somewhere. It's a little bit off the grid. It's pi over 3 in this direction. And then keep in mind, our period is 2 pi over 3. So we went backwards pi over 3. That means the whole graph is going to only go to pi over 3 this way. Now pi over 3 in reality is somewhere between pi over 4 and pi over 2. So it's probably in this ballpark right here. And that's the entire period of this particular function. It's narrow, right? It's squished together. Once you get your 2 dots down, you know that you're at your low point in between those. So for us, it's going to be right on the y-axis because we went pi over 3 backwards and we're going pi over 3 forwards. Remember, this is a little squished over here on the left, but that's the deal. And then between these two, you know that we have a 0 here and a 0 here. So essentially, what we have for one cycle is we have this thing coming through like this, bopping down and coming back up. And then remember that happens over and over again. So from pi over 3 to pi, we fit another one of those in there, and it's going to go halfway. It's going to go down and up again to get to there. That continues this way. But I've been asking you to draw one cycle, and if you're only drawing one cycle, you're going to be a little squished because I didn't give you a lot of room on that side. Let me show you that the way I did graph this, even though I had to squish it there on the left, is actually what this graph should look like. I'm just going to run through Desmos and show you that we've got it, okay? So I went ahead and I did graph the, oops, that's supposed to be a highlighter. I did graph the original cosine function just as a reference, just like I had in the sheet that I gave you. Here it is down here. And then here's that graph that we just drew. Okay, and in particular, notice that I did shift backwards to negative pi over 3, and then because the period's 2 pi, we end at pi over 3, so that's this piece that we drew. That's one cycle. And then because I was so far off the screen, I went ahead and drew a second cycle in, and notice that one ended at pi, just like the one we drew. So although the graph wasn't set up as well as I intended for this problem, you are able to draw this thing, and it's not the end of the world if you have to fudge a few numbers to figure out where pi over 3 is on the axis down here. So don't panic. There's fudge room on these. You're never going to draw a perfect graph. And if you have to, you can always peek at decimals to see if you're on the right track. So good luck on the other 5 graphs. Keep up the good work. If you have questions, we will talk about it next time you see me. Take care.